Forbidden Truth revealed how Buddha unlocked quantum reality 600 years ago. Modern physics is in the midst of a profound crisis. At the smallest scales of nature, the comfortable certainties of classical science break down into paradoxes and probabilities. Experiments show that particles can be in two places at once, that observation itself seems to decide what is real, and that distant objects can be mysteriously linked across space. These quantum revelations have forced physicists to ask questions that sound almost spiritual. Does the moon exist if no one is looking? What is reality when no one observes it? Could it be that reality is not a fixed thing out there, independent of us, as we long assumed? The famed physicist John Wheeler once mused, "No phenomenon is a real phenomenon until it is an observed phenomenon." Such statements capture the perplexity of the quantum crisis, a crisis where science finds the very notion of an objective, observer-independent reality under siege. This video will take you on a journey through two worlds of thought: cutting-edge quantum physics and ancient Buddhist philosophy. We will see step by step how quantum mechanics, with its wave-particle duality, uncertainty principle, observer effect, and spooky entanglement, has arrived at a puzzling crossroads. Its greatest minds, Einstein, Bohr, Heisenberg, Schrödinger, Feynman, and others, struggled to interpret what quantum experiments mean about the nature of reality. Remarkably, at this same crossroads, we find signposts that the Buddha set up 600 years ago. In the teachings of Theravada Buddhism, preserved in the Pali Canon, we find profound insights into the nature of mind and phenomena that directly address these quantum dilemmas. Buddhism teaches a view of reality as dependently originated paticca samuppada, impermanent anicca, and devoid of any fixed essence anattā. It emphasizes the role of consciousness vijnana and perception sanya in creating the world we experience. These principles, as we will see, resonate uncannily with the baffling findings of quantum physics and resolve them in a surprisingly elegant way. Imagine a framework in which reality isn't a static, objective container of things, but an ever-changing flow of events that arise when conditions, including an observer, are present. What if the observer is not a disturbance to reality, but an integral part of it? What if the crisis in quantum physics is pointing science toward a truth that the Buddha awakened to under the Bodhi tree, a truth about the mind-dependent nature of the world? Could the answers to physics' most confounding questions have been discovered by a sage in India millennia ago? Let's find out. 1. Quantum physics crisis. Explained. At the dawn of the 20th century, physics stood proudly on the firm ground of Newtonian mechanics. Reality seemed straightforward. Matter was made of solid particles following definite laws, cause led to effect with clockwork certainty, and an objective world out there existed independently of observers. Sir Isaac Newton's classical physics had reigned for over 2 centuries, describing planets and projectiles with precision. By the late 1800s, many scientists believed physics had nearly figured out the fundamentals of nature. Little did they know, the ground under their feet was about to crack. A series of startling discoveries broke the classical mold and pushed physics into the strange and subversive realm of quantum mechanics. The cracks first appeared with puzzling phenomena like the photoelectric effect explained by Einstein in 1905, showing light behaving as particles, and the discrete spectra of atoms suggesting electrons had quantized energy levels. But the truly paradigm-shattering experiment was the now famous double-slit experiment. Let's recount this landmark demonstration as its implications form the crux of the quantum crisis. Imagine firing a beam of electrons or photons at a screen with 2 narrow slits, and behind that a detector screen to catch where the particles land. If one slit is open, Electrons pass through it and form a single band on the detector, just as bullets or tiny pellets would. But if both slits are open, something eerie happens. Instead of forming two bands, the electrons create a pattern of alternating light and dark fringes, an interference pattern, as if waves had passed through both slits and interfered with each other. Yet, electrons are particles, right? How can a single electron go through both slits like a wave and interfere with itself? Quantum theory's answer: each electron exists as a wave of probability, a spread-out wave function that encompasses all possibilities. It isn't a localized thing going through one path. It's as if it goes through both paths until it is detected, at which point the wave function collapses to a point. As mystifying as that sounds, even weirder was yet to come. Physicists placed detectors at the slits to see which slit each electron actually went through. Surprisingly, the very act of observing the electron destroys the interference pattern. If you watch the slits, electrons behave like ordinary particles, forming two clumps behind the slits, no interference. If you don't watch, they act like waves interference. In other words, the outcome changes depending on whether an observation is made. The electron seems to decide on a definite path only when measured. This is known as the observer effect in quantum mechanics. Observation itself affects the system. More precisely, any interaction that yields information about the electron's path, even an automated detector, not necessarily a conscious mind, will collapse the electron's spread-out state into a single outcome. This isn't just a cute quirk. It strikes at the heart of what we mean by reality. Does the electron have a definite position or path when no one observes it, or is it only real when measured? Quantum mechanics suggests the latter, a notion that deeply disturbed many great scientists. One of the founders of quantum theory, Werner Heisenberg, expressed it clearly. What we observe is not nature itself, but nature exposed to our method of questioning. In other words, we never see an objective nature with no observer, we see results of our interactions with nature. The properties of particles like position or momentum seem to exist only in the context of a measurement. If that sounds philosophical, it is quantum physics forced physicists to become philosophers. Heisenberg's own uncertainty principle encapsulated this one: cannot simultaneously know certain pairs of properties like position and momentum to arbitrary precision. The more precisely you pin down an electron's position, the more uncertain its momentum becomes, and vice versa. This is not due to measurement errors. It's indicating a fundamental fuzziness in nature. An electron doesn't have a sharply defined position and momentum at the same time. Reality at that scale is partly indeterminate until an observation forces a choice. Erwin Schrödinger, another pioneer, formulated a thought experiment to dramatize the absurdity of this indeterminacy if applied to everyday objects: Schrödinger's cat. In this scenario, a cat is sealed in a box with a deadly poison that will be released if a quantum event, say the decay of a radioactive atom, occurs. According to the quantum formalism, until we open the box to observe, the atom is in a superposition of decayed and not decayed, and by extension the cat would be in a superposition of alive and dead. This was intended as a reductio ad absurdum, a critique showing that something is amiss if our theory implies a cat can be simultaneously alive and dead. Yet until a measurement opening the box happens, quantum theory does imply a lack of single reality. When you do open the box, you find a single outcome, either a happy kitty or a dead kitty. But when did it decide? The thought experiment highlights the unresolved measurement problem. At what point does a fuzzy both states at once quantum system collapse into the concrete reality we observe? Albert Einstein, though instrumental in the quantum revolution, he explained the photoelectric effect and contributed to early quantum ideas, was deeply dissatisfied with this new picture of reality. He famously remarked in a 1926 letter, "I at any rate am convinced that he, God, does not play dice with the universe." Einstein bristled at the idea that nature at its core is governed by probabilities and randomness, that there is no objective reality with definite properties, only potentialities that become real upon observation. In another anecdote, Einstein asked physicist Abraham Pais whether he believed the moon exists only when someone looks at it, implying his incredulity at the notion that observation creates reality. Einstein, a realist, believed the world should have determinate properties whether or not anyone is measuring them. Opposing Einstein was the camp led by Niels Bohr, a founding father of quantum theory, and the architect of the Copenhagen interpretation, the first, and for a long time dominant interpretation of quantum mechanics. Bohr urged that we relinquish classical intuitions about an objective reality and accept the quantum facts. The act of measurement is fundamental, and we cannot speak of a quantum system having properties like the electron went through slit A until they are observed. In Bohr's words, there is no quantum world. There is only an abstract quantum physical description. It is wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature. This startling claim means physics must drop the notion of an independent reality and focus on the relationships between observations and the knowledge we can acquire. Bohr's viewpoint was that the question what is really happening to the electron is meaningless. All we can talk about is what we observe under specific experimental setups. These debates came to a head in 1935 with the famous EPR paradox proposed by Einstein, Podolsky, and Rosen, and Bohr's response. Einstein and colleagues proposed a thought experiment to show that quantum mechanics as it stood was incomplete. They described a situation with entangled particles, two particles that interact and then fly far apart. Quantum theory said their properties could remain correlated in such a way that measuring one particle instantaneously affects the state of the other, no matter the distance between them. Einstein derisively called this spookhafte Fernwirkung, spooky action at a distance, because it seemed to violate the principle of locality that nothing can influence something else faster than light. To Einstein, this suggested that there must be some deeper hidden reality, often called hidden variables, carrying definite values and providing a mechanism for those correlations so that no instantaneous magic is needed. Bohr, however, maintained that quantum theory was complete and that no hidden variables were needed. Entanglement simply meant nature is non-local or non-separable at the quantum level. Decades later, experiments by Alain Aspect and others in the 1980s and even cosmic scale tests in recent years showed that Einstein's intuitions were wrong. Entanglement is real and yields correlations that cannot be explained by any local hidden variables. Thus, there really is a kind of instantaneous connection, or else one must abandon the idea that particles have pre-existing values before measurement. Many physicists have concluded that we must give up local realism. You can't have both locality and an observer-independent reality. Quantum mechanics stands vindicated, and Einstein's realist view has taken a hit. But this victory of quantum theory leaves us with a universe profoundly different from the classical image. Let's pause and digest the quantum crisis in plain terms. By the mid-20th century, experiments and theory were telling us that a quantum object like an electron or photon is not either a wave or a particle. It's described by a wave function encoding probabilities of different outcomes. It exhibits wave-like behavior interference when not observed, yet yields particle-like clicks when detected. This wave-particle duality defies our everyday categories. Outcomes of experiments are fundamentally probabilistic. You cannot predict with certainty where one electron will hit the screen, only the odds. Einstein hated this insisting God does not play dice, but experiments support the probabilistic nature. Reality at base seems to have chance built in, a radical break from deterministic classical physics. The act of measurement affects the system in a way that cannot be removed. This isn't just a technical inconvenience. It suggests that properties do not exist in a definite way prior to measurement. As Pascual Jordan, another quantum pioneer, put it, observations not only disturb what is to be measured, they produce it. We compel the electron to assume a definite position. We ourselves produce the results of measurement. In other words, measuring an electron's position forces the electron into having a position. Before that, it didn't have a singular position. This is a staggering shift from the classical paradigm where measurement simply reveals a pre-existing property. Entangled particles break the usual notion of separateness. If two particles are entangled, measuring one instantly sets the state of the other, even if they are light years apart. It's as if the two particles form a single system with a shared existence. The idea of independent objects with their own individual states falls apart here. Only the relationship is real until observation. As one description put it, entanglement means the acquisition of a value of a property at one location happens as a result of a measurement at a distant location. Reality, it appears, is deeply interconnected in a way that transcends space. No wonder Richard Feynman said, "I think I can safely say that nobody understands quantum mechanics." It's not that the theory doesn't work. It predicts experimental results with astounding accuracy. But what the theory implies about reality left even its creators baffled and divided. Feynman also joked that if you meet someone who claims to fully understand what quantum mechanics means, then you haven't understood the first thing about it. The situation was and remains a philosophical quagmire. Is an electron real when no one looks? Does consciousness have a special role in making things actual? Are there countless parallel worlds, as the many worlds interpretation suggests, where each possible outcome actually happens in a branching universe? Or is the whole question moot because physics should only deal with observable predictions and not inquire about an underlying reality, the strict Copenhagen view? This is the quantum crisis. Physics, in trying to probe the foundations of the material world, has found that material reality dissolves into something ghostly and elusive. The solid, independent objects of classical physics turned out to be mostly empty space at the atomic level, and at the subatomic level, even the particles are described by abstract wave functions. An electron is nowhere in particular until it is observed, and then it is somewhere. An atom's energy is not continuous but comes in discrete quanta. Cause and effect can be non-local. Reality, it seems, depends on the context, on how we choose to observe. As Niels Bohr observed, the old distinction between the observer and the observed breaks down. They form an indivisible whole during a measurement interaction. The Cartesian split between the I subject and the world object that underpinned science for centuries was upended by quantum findings. Physicists reacted to this crisis in different ways. Some, like Bohr and Heisenberg, leaned into the weirdness and essentially said, "This is how nature is, take it or leave it. Our classical intuitions are just wrong." Others, like Einstein, de Broglie, and later David Bohm, sought ways to preserve a realist picture. Bohm, for example, developed an interpretation where particles have definite positions at all times but are guided by a pilot wave. Others postulated an infinity of parallel universes to avoid collapse. Meanwhile, another group, Eugene Wigner and John von Neumann, entertained that consciousness might be the key, that perhaps a conscious observer is needed to collapse the wave function. This idea that mind is special in quantum mechanics is still speculative and not universally accepted, but it shows how quantum mechanics forced even hard-nosed scientists to consider the role of the observer something bordering on philosophical or even mystical territory. In recent decades, most physicists have settled into pragmatic acceptance. Shut up and calculate is a phrase that captures the reluctance to philosophize. But the foundational questions haven't gone away. In summary, quantum physics in the early 21st century sits with these unresolved questions. What is the nature of reality when we're not looking? Is the wave function just a calculation tool? Or is it something real out there? If it's real, why does it collapse upon observation? If it's not real, then how do particles decide on outcomes? What does entanglement say about the fabric of the universe? These are not fringe questions. They strike at the core of physics. As a 2019 article in Nature bluntly stated, why, after nearly a century of debate, do we still lack a clear picture of reality at the quantum level? Some physicists feel almost metaphysical, perhaps reality as we conceive it, separate objects with intrinsic properties, is an illusion. This is where we pivot to the second layer of our exploration: Buddhism. It might seem unlikely. What could an ancient spiritual tradition offer to cutting-edge quantum conundrums? But as we shall see, the Buddhist Dharma teaching directly tackles the apparent duality of observer and observe the contingent nature of phenomena and the absence of intrinsic essence in all things. In the Buddhist view, the crisis only arises if we insist on interpreting the world in terms of inherently existing things. Buddhism offers instead a process view of reality that may turn the quantum paradoxes from mysteries into expected features of nature. In the next chapter, we will clearly outline Buddhism's understanding of reality, drawing straight from the Buddha's discourses, the Nikayas. As we go along, you may notice that the Buddha's explanations sound as if they were custom-made to answer quantum physics, even though they were taught millennia ago for an entirely different purpose: to end suffering by dispelling ignorance about the nature of existence. It's a testament to the depth of those insights that they remain highly relevant to the most advanced scientific dilemmas of our time. 2. Buddhism's unique understanding of reality. Let us leave the lab and the thought experiment for a moment and enter the domain of the Buddha's teachings. 26 centuries ago, far from any particle accelerators or mathematics, Siddhartha Gautama, the Buddha attained enlightenment through meditation and introspection. What he awakened to was a profound understanding of nature of reality and mind, so profound that his teachings have guided spiritual seekers ever since. The remarkable thing is that the Buddha did not frame his insight as dogma or mysticism, but as a phenomenological analysis of experience. He encouraged empirical verification. Ehipassiko, he said, come and see for yourself. In the Kalama Sutta, AN 3. 65, often called the Buddha's Charter of Free Inquiry, he told people not to believe something just because it's a tradition scripture or taught by a teacher, but to test it in their own experience. This attitude resonates strongly with the scientific spirit. Buddhism at its core is about understanding reality through direct observation and logical inference, albeit through introspection and ethical living rather than external experimentation. Now, Buddhism's primary motivation is to address the problem of suffering dukkha and achieve liberation nirvana. But to do so, the Buddha delved deeply into the nature of existence. In doing so, he described reality in a way that strikingly parallels some conclusions of quantum physics, though for entirely different reasons. Let's outline the key principles of the Buddhist worldview. Dependent origination, paticca samuppada, the law of conditionality. At the heart of the Buddha's insight is the principle that all phenomena exist in dependence on other phenomena. Nothing exists independently or by its own essence. This is the doctrine of dependent origination, in Pali paticca samuppada. It is sometimes phrased in a concise formula taught by the Buddha. When this exists, that comes to be. with the arising of this that arises. When this does not exist, that does not come to be, with the cessation of this that ceases. This simple verse, almost scientific in its generality, states that everything arises due to causes and conditions. There are no absolute uncaused entities in Buddhist philosophy. Everything physical or mental is part of a web of conditions. The Buddha emphasized that this principle is an essential reality. Whether Tathagata's enlightened ones arise or not, this law remains as a fixed nature of things. This law of conditionality, idapakayata, is called dependent arising. He regarded it as a discovery, not an invention, a universal natural law akin to gravity, or one might say akin to the fundamental laws physics seeks. The most famous application of this principle is the 12-link chain of dependent origination, which explains how suffering arises and how it ceases. The 12 links. Devadasa Nidanani form a cycle describing the rounds of rebirth and suffering, but they also can be understood as describing the arising of experience in each moment. They go as follows in sequence: ignorance avijja, volitional formations sankhara, consciousness vijnana, name and form namarupa, six sense bases salayatana, contact phasa, feeling vedana, craving tanha, clinging upadana, becoming existence bhava, birth jati, aging and death jara marana. This may sound complex, but a crucial segment of it often highlighted in Buddhist analyses is the feedback loop between consciousness and name and form. Name and form means the mental and physical constituents of experience, mind, and body. The chain states, conditioned by ignorance, volitional formations arise. Conditioned by formations, consciousness arises. Conditioned by consciousness, name and form, mind-body arises. Conditioned by name and form, the six senses arise. Conditioned by the six senses, contact. Conditioned by contact, feeling, and so on. This indicates that consciousness, the knowing faculty, cannot arise without an object, the mental physical phenomena, and conversely, the world of experience, nama-rupa, cannot manifest without consciousness. They are interdependent. The Mahanidana Sutta DN 15 makes this explicit with an analogy. Consciousness and name and form are like two sheaves of reeds propped up against each other, each standing only because the other does. If one is removed, the other collapses. In Ven Sariputta's words from that discourse, from consciousness as a requisite condition comes name and form. From name and form as a requisite condition comes consciousness. This is a profound idea. The subject consciousness and object, the experienced world of name form, arise together and depend on each other. There is no consciousness without something to be conscious of, and no experienced world without consciousness to perceive it. Consider how revolutionary this interdependence is compared to common views. It avoids the extremes of materialism, which might say matter is primary and produces consciousness as a byproduct, and idealism, which might say mind is primary and produces matter as a mental construct. Buddhism is charting a middle way. Mind and matter arise in mutual dependence, neither reducible purely to the other, neither able to exist in the experiential sense without the other. This is a nuanced ontological stance that differs from Western philosophical dualism too. It's not saying there are two separate substances, mind versus matter. Rather, it's saying the distinction itself is conceptual, and in lived experience they are two sides of the same coin of dependent events. Let's also parse what is meant by name and form. Name nama in this context refers to the mental constituents, feelings, perceptions, intentions, attention, etc. Basically, the mind's qualities. Form rupa refers to physical form, the material aspect. So, nama-rupa together represent the entirety of an individual existence's psychophysical process. Dependent origination asserts that it is through consciousness coming into being that a seemingly concrete world comes into being and vice versa. This is strikingly resonant with the quantum idea that the observer and observed are not independent. Recall Bohr's comment that separating the world into objective and subjective sides is too arbitrary. Buddhism said as much long ago, the world as experienced is a product of both object and subject in tandem. Impermanence, anicca, universal flux. Another cornerstone of the Buddha's teaching is impermanence anicca. All conditioned phenomena from a subatomic particle to a thought in the mind arise and pass away. They have no enduring stability. Sabbe Sankara Anicca goes a famous phrase, all conditioned things are impermanent. The Buddha taught that everything is in constant change, and failure to realize this leads to attachment and suffering. In the Anicca Sutta, SN 22.15, the Buddha makes a logical case. Form rupa is impermanent. What is impermanent is suffering dukkha. What is suffering is not self-anattā. He repeats this for each of the 5 aggregates: form, feeling, perception, mental formations, consciousness. The takeaway is that because things are impermanent, they cannot ultimately satisfy, they are dukkha, unsatisfactory. And because they are impermanent and unsatisfactory, they cannot be taken as me or mine, thus are not self. We will speak about not self next, but first impermanence in a more general sense. The Buddha described the momentary nature of consciousness in vivid terms. Consciousness, monks, is in constant flux, arising and ceasing anew every moment, day and night, like a monkey swinging from branch to branch. Indeed, he pointed out that one might mistakenly assume the physical body to be self. It at least persists identifiable for years, but one cannot even imagine the ever-changing flicker of the mind to be a self. It changes far too rapidly. Modern neuroscience echoes this. Our sense of a continuous self is an illusion. The brain-mind is a flurry of evanescent processes. In quantum physics, too, we found that trying to pin down a particle's exact attributes is futile. The more we try, the more nature blurs them uncertainty. In classical physics, an electron orbiting an atom could be seen as a tiny planet in a stable orbit. In quantum physics, an electron in an atom is more like a cloud of probability, only choosing a definite state when interacting. This is anicca writ small. There is no fixed being, only a becoming. The Buddhist concept of sabhava shunyata, emptiness of inherent existence, is tied to impermanence. Nothing has being, everything has becoming. It's worth noting that even Einstein's relativity, though a classical theory, introduced a kind of impermanence of facts, simultaneity of events became relative to observers. Bohr commented on this as a liberation of thought, how physics had to accept that what we thought was absolute time simultaneity is relative to frames. In quantum theory, the departure from the classical ideal of objective description is even more radical, Bohr said. Buddhism would nod in agreement, clinging to the idea of fixed absolute states is a form of ignorance, avidya. Wisdom panya sees the transient conditioned nature of all that is. Not self, anattā. No independent essence. If everything arises from conditions and everything is in constant flux, it follows that nothing whatsoever has an unchanging essence or self. Anattā, or Anatman in Sanskrit, is the teaching that there is no permanent autonomous self or soul inside any being or object. What we call a person or a thing is just a convenient label on a collection of processes. The Buddha analyzed a person into the 5 aggregates, panchakhanda: form, feeling, perception, mental formations, and consciousness, none of which is self, and none of which persist unchanged even for a moment. In the Anattā Sutta, SN 22.59, the Buddha systematically went through each aggregate asking, Is this permanent or impermanent? What is impermanent? Is it satisfactory or unsatisfactory? What is impermanent, unsatisfactory, and subject to change? Is it fit to be regarded as, this is mine, this I am, this is myself? The monks answered no each time. The Buddha concluded that one should view all form, feeling, etc. In that way, this is not mine, not I, not myself. Applied broadly, not self means nothing has an independent permanent identity, neither persons nor particles. There is a striking parallel here with the quantum revelation that properties aren't fixed prior to observation, and with the notion, especially in some interpretations, that particles don't have a definite existence as individualized entities with their own being apart from the system or context. Buddhism takes this even further. Not only do particles not have fixed essence, but our very sense of I is an ever-changing bundle with no core. One may ask, if there is no self, what is it that experiences the world? Buddhism's answer: experience is just a stream of dependently originated events, the aggregates interacting. Consciousness vijnana itself is not a monolithic soul entity, but a process that arises dependent on conditions like sense organ plus object. It's said to be momentary and conditioned. In fact, consciousness is dependently arisen and ceases when its conditions cease. There is a provocative dialogue in the scriptures where a monk named Sati held a wrong view that this same consciousness runs and wanders through the rounds of rebirth, essentially an eternalist view of consciousness. The Buddha reprimanded him and clarified that consciousness is dependently arisen at each moment based on conditions, the specific sense base, and object and attention. There is no single consciousness that transmigrates or persists unchanged. See MN 38 Mahatanha Sankhya Sutta. This is important for our comparison. Buddhism would not agree with the notion of a single cosmic mind or one eternal consciousness underlying all of you found in some Hindu philosophies or in Schrödinger's Vedantic leanings. Instead, it views even consciousness as a conditioned phenomenon empty of self. In a sense, all aspects of reality are relational rather than essential. They exist in relation as dependencies, not as self-sufficient entities. We can bring this back to physics. The failure to find a definite localized particle until measurement, the inability to ascribe reality to the electrons, which path info until observed. These echo anattā of those properties. They do not exist from their own side. Einstein's discomfort was that, without assuming an objective reality, physics felt incomplete. But Bohr and Heisenberg essentially said, no, that is the reality. A reality where properties are not intrinsic, but emerge through interaction. This is quite aligned with anattā and paticca samuppada. No particle has self-nature. Its properties manifest only through dependent relations like interactions, measurements. The all-sabba-a defined scope of reality tied to experience. Buddhism makes a very interesting move in SN 35.23 Sabba Sutta, the All. The Buddha says, "Monks, I will teach you the All." Listen. What is the all? Simply the eye and forms ear and sounds nose and aromas, tongue and flavors body, and tangibles mind and ideas. This monks is called the all. Asterisk asterisk. Anyone who would say repudiating this, all I will describe another if questioned on what exactly might be the grounds for his statement would be unable to explain, and furthermore would be put to grief. Why? Because it lies beyond range. This concise sutta defines the entirety of reality, the all as the six sense bases and their objects, including mind mano and mental objects Dhamma. In other words, whatever can be experienced or known, that is the all. Anything beyond that is beyond range, that is beyond what can even be meaningfully talked about. This is a very pragmatic delimitation of reality. The Buddha is effectively saying, if you claim something exists outside of any possible experience or observation. Note in Buddhism, observation can be through any sense, including mental intuition. Such a claim is empty. It must, at least in principle, make contact with the senses' mind to be considered part of reality. This sutta resonates with the spirit of Bohr's statement that physics concerns what we can say about nature, not about how nature is in an absolute sense. The Buddha similarly focuses on phenomena as experienced phenomenology. We find here a stark parallel. Quantum physics ended up saying we must restrict ourselves to the domain of observation, measurement, and Buddhism long ago said the all is the domain of the six senses. Talk of any reality outside of that is meaningless. Consider the implication from the Buddhist perspective, asking, but what is really there? When no sense is cognizing, it is misguided. It's beyond the all. Reality for us is necessarily a reality perceived or cognized. This doesn't mean a rock ceases to exist when no one is around. It means rock is a concept based on seeing or touching, etc. If absolutely no consciousness could ever know or experience something, it's equivalent to non-existence for all practical purposes. In modern terms, it's a kind of empirical non-realism. Only the empirically accessible counts as real. Does that not sound like one of the interpretations of quantum mechanics? Indeed, the quantum Bayesian interpretation and others have taken similar philosophical positions. That quantum states reflect information and potential experience, not objective elements of reality. While Buddhism is not talking about electrons per se, it is asserting a principle that sidesteps the quantum measurement paradox. Reality is inherently tied to the interplay of consciousness and its objects. An unobserved reality is an incoherent notion. Come and see the empirical non-speculative approach. Finally, it's worth noting how the Buddhist approach to knowledge contrasts with speculative or metaphysical approaches. The Buddha was famously reluctant to entertain metaphysical questions that did not conduce to enlightenment. For example, he would not be drawn on whether the universe is eternal or not, infinite, or not whether an enlightened one exists after death or not, etc. He likened such metaphysical distractions to a man wounded by an arrow who, instead of pulling it out, demands to know who made the arrow, what kind of wood, etc. The pragmatic thrust was focus on the problem of suffering and its cessation by understanding the principles of dependent origination and not self in your own experience. This is encapsulated in the Kalama Sutta we touched on. Do not go by reports, by legends, by traditions, by scripture logical conjecture, or by the thought, this venerable is our teacher. When you know for yourselves that certain qualities are unwholesome and lead to harm, abandon them. When you know for yourselves that certain qualities are wholesome and lead to welfare and happiness, adopt them. This spirit is empirical and ethically grounded. The Buddha essentially says, verify through experience. In a way, this foreshadowed the scientific method of testing hypotheses, though applied inwardly and morally. It guards Buddhism from becoming a mere dogma. When Buddhism states all phenomena are empty of self, or the world is dependently originated, it also provides ways to observe these truths directly. In meditation, practitioners carefully examine the arising and passing of sensations, thoughts, and feelings, observing their conditionality and fleeting nature. At advanced levels, some meditators report directly seeing the mind-matter process flickering moment to moment, confirming the texts that talk about the momentariness of phenomena. In summary, Buddhism's unique understanding of reality can be summed up in a few key tenets. Reality is dependently originated. Nothing exists from its own side. Things exist only in relation to other conditions. This interdependence is universal, applying to mind and matter alike. All conditioned phenomena are impermanent. There is a constant arising and ceasing. Stability is an illusion. Because phenomena are impermanent and contingent, they are not self. There is no unchanging essence or soul in them. Self is a convenient fiction, whereas, in reality, there is just a dynamic process. The experiential world, the all, is defined by the interaction of consciousness and its objects. Nothing lies outside this all in any discussable way. Hence, reality as we can know it is inherently tied to experience, the interplay of observer and observed. Knowledge should be tested and seen directly. One is invited to observe these truths in the laboratory of one's own mind and life, rather than just accepting them blindly. Having laid out these principles, one might already suspect how they speak to the quantum conundrums. But let's make it explicit in the next chapter. We will align the quantum crisis phenomena with the Buddhist insights and see how point-by-point Buddhism provides a resolution, or at least a reframing that dissolves the mystery. It's important to stress the Buddha was not trying to solve physics problems. He was addressing the human condition of suffering. Yet by penetrating the nature of reality so deeply, he arrived at truths that are startlingly applicable to the philosophical puzzles quantum physics presents. In a sense, modern physics is catching up to some of the philosophical insights that an ancient contemplative tradition arrived at through introspection. The dialogue between these two can be immensely enriching, as we are about to explore. 3. Buddhist resolution of quantum dilemmas. It's time to bring the two strands together. We have on one side the quantum dilemmas, observer-dependent reality uncertainty, wave function collapse entanglement, the conflict between classical intuition and quantum facts. On the other side, we have Buddhist insights, dependent origination, the unity of observer and observed impermanence, non-self, and the primacy of experience. Let's match them and see how Buddhism can effectively resolve or clarify the quantum mysteries. Quantum dilemma, one observer-dependent reality measurement problem. In quantum physics, as we saw, an unobserved phenomenon often can't be said to have happened in a determinate way. The double-slit experiment encapsulates this interference occurs when you don't observe which path the electron takes. If you observe, the interference vanishes and you get particle-like behavior. The question arises, is the electron's behavior decided by the observer? Does consciousness cause the collapse of the wave function? Physicists debate if it's the conscious observer or simply interaction with any measuring device that causes collapse. But either way, we have observer or apparatus entangled with the system. The sharp classical divide between observer and independent system breaks down. Buddhist resolution Buddhism would say, of course, the observed phenomenon isn't independent. It never was. The observer and observed arise together as interdependent aspects of experience. The Sabasuta's lesson that the all is the senses and their objects means that an electron's manifested property, say a definite position on a screen, exists in the context of a sensory event. In this case, an interaction with a detector which is observed. Prior to that interaction, speaking of the electron's actual position has no meaning in Buddhism because it's outside the realm of any possible experience. Buddhism wouldn't be surprised that we can't ascribe reality to an electron's path when it's unobserved. That's exactly what beyond the all implies. Furthermore, Buddhism's dependent origination posits that the act of knowing consciousness and the known world name and form co-create each other in each moment. So when the measurement happens, that's precisely the coming together of conditions to create a determinate event vijnana meeting nama-rupa at one point. Before that, the pieces electron apparatus, etc., were in flux and not crystallized into a specific outcome. In technical Buddhist terms, one could say the electron's wave function is like a sankhara formation, a range of potentials. Only when it meets vijnana consciousness and nama-rupa in an act of phassa contact do we get a specific vijnana of that event and a form rupa manifested. This is analogous to collapse but described in experiential terms. Does this mean consciousness causes collapse? Not exactly in a simplistic sense. Buddhism would say any condition that leads to an experience will collapse potential into actual experience. A photographic plate or electronic detector can be seen as part of the chain of conditions that eventually results in a mind knowing the detector registered a hit at that spot. Consciousness in Buddhism is always consciousness of something arising in dependency. The chain might be electron interacts with detector physical event detector records, mark later a scientist observes the detector. At that final stage, there is a mind-object contact and the event becomes part of the all of experience. One could argue from a Buddhist view that before an event is at least recorded in some way, it's not really existent as a definite phenomenon. This aligns with interpretations of quantum mechanics that say outcomes are not real until registered by an irreversible amplification in a detector, which in turn eventually is observed by a conscious mind. Notably, some physicists like John Wheeler even proposed experiments, the delayed choice experiment, that suggests it's as if observation retroactively defines whether something happened as a wave or particle. This is mind-bending for classical thinking, but Buddhistically time and sequence are themselves part of the experience and dependently originated. Even retrocausality thoughts can be entertained when one removes absolute time, though we won't digress there. To summarize this point, Buddhism dissolves the measurement problem by denying the premise that there's a hard ontological split between the observer and the observed. Since all we ever deal with is the interplay of consciousness and phenomena, it's no shock that phenomena require observation to show up. As the Buddha said in SN 12.67, take away consciousness and the world of experience collapses. Take away the object nama rupa and consciousness collapses. Thus, a quantum particle doesn't have a single reality by itself. Its reality is event-based, coming into being when conditions coalesce, including the observer condition. The so-called observer effect ceases to be a puzzling intrusion. It is expected. Reality is observer-dependent not as a quirk, but as a fundamental truth. A truth Buddhism recognized in saying the world is essentially the six senses and their objects, nothing more. Now, one might worry, does this verge into solipsism? Only my mind exists. Not in Buddhism, because Buddhism does not say only mind is real. It says mind and its objects arise together. The world is real as experienced, and multiple beings have their own streams of experience. Buddhism would interpret that different observers see consistent results due to shared karma and common causal conditions, not because there's a fixed world, but because there is an intersubjective continuity in the dependently arisen network we all partake in. In quantum terms, one could liken it to the idea that while outcomes aren't fixed until observed, there is an underlying order, quantum probabilities, the wave function that ensures coherence and statistical regularity across observers. Buddhism would call that underlying order Dhamma Niyama, law of nature, the law of karma, cause and effect, etc. We might consider the wave function as akin to a set of conditions pakaya that, given a certain observation context, yield a specific outcome. But until the intersection with consciousness or measuring apparatus, those conditions haven't precipitated an event. Quantum Dilemma 2: The Uncertainty Principle and Indeterminacy. Heisenberg's uncertainty principle says you cannot know certain pairs of properties beyond certain precision. More philosophically, it implies that particles do not have exact values for those properties simultaneously. This shattered the classical ideal that with enough information one could predict everything Laplace's demon cannot exist in a quantum world. So there is a fundamental indeterminacy or fuzziness. Buddhist resolution Buddhism teaches that trying to pin down reality into fixed, unchanging entities is a source of delusion. All conditioned things are marked by impermanence, anicca, and what's called in some texts, insubstantiality. The Buddha often used the analogy of a lump of foam or a mirage to describe the aggregate components of a person's being. They appear solid, but when inspected closely, they are empty of core. In the Kaccanagotta Sutta, SN 12.15, the Buddha said that the world usually falls into two views, existence anattā and non-existence anattā. But one who sees with right wisdom does not assume either extreme. One sees that what arises dependently, not as absolute existence, and what ceases dependently, not plunging into non-existence. This subtle view avoids saying things truly exist and also avoids saying things don't exist at all. Instead, it says things exist in a conditioned, transient manner. This is very relevant to quantum indeterminacy. It's as if quantum entities neither exist in a classical sense, nor are they non-existent. They have a potential existence, you might say existence in dependence on measurement context. They are emptiness in motion. The Buddha's middle way is conceptually similar to the idea that an electron is neither a particle with definite existence here or there, nor a wave in a physical medium like classical wave, but something that cannot be grasped by those categories. Buddhism's view of impermanence also implies that you cannot know everything about a thing at once, because by the time you measure one aspect, the other aspect has changed. In fact, this very reasoning appears in Abhidhamma discussions. For instance, you cannot have a single siddha-mind moment apprehend multiple things at the exact same time. Reality is a rapid succession of momentary events. This resonates loosely with how the act of measuring momentum disturbs position and vice versa. It's as if nature will not yield an absolute static picture because there is no static picture to be had. The fluidity of existence means knowledge itself must have a certain uncertainty built in. The uncertainty principle and the notion that certain things are inherently unknowable, like you can't know a particle's path and interference pattern at once. It's one or the other finds an echo in Buddhist epistemology. In conventional reality, we use concepts and measurements, but when probing ultimate reality, those concepts break down. The Buddha stated there are questions that do not apply, like the famous tetralemma questions about the Tathagata. After death exists, non-exists both or neither. None of the above, because those concepts don't apply to one who's beyond conditioned existence. This is akin to asking a quantum particle, which slit did you go through? The answer may be, it's not in the scope of that situation to say it went through one or the other. It's not just unknowable. It's undefined until a context forces it. Buddhism similarly says, many of our metaphysical questions are wrongly posed. Reality isn't obliged to answer in our binary terms. Quantum dilemma, 3 superposition and Schrödinger's cat paradox. Quantum theory allows systems to be in superposition, multiple states at once, until observed. Schrödinger's cat paradox highlights how bizarre this is when scaled up a cat seemingly both dead and alive until observation. The reality of the cat is indeterminate in that scenario. Buddhist resolution Buddhism might smile at this paradox because it has its own way of saying that concepts like alive and dead are ultimately conceptual proliferations that don't capture the subtler reality. The cat in the thought experiment is entangled with the quantum system, making it effectively a quantum system itself. In Buddhist terms, we'd say a being status as alive or dead is dependently originated on conditions, heartbeat, brain activity, etc. But in a borderline scenario, those conditions can be in flux. Consider the Buddhist perspective on life and death. There's a moment-to-moment arising and ceasing of phenomena. A living body is one that has the conditions for consciousness to arise in it. A dead body lacks that. In the cat paradox, until the measurement the conditions are in limbo, the isotope may be decayed or not. Buddhism wouldn't actually allow a cat to be both alive and dead from the cat's own perspective. If it's alive, it's having experience. If dead, no consciousness in that form. But it would say from the external observer's perspective, the cat's status is undetermined until checked. This is not an issue in Buddhism because ontology, what truly is always framed by perspective and conditions. If no consciousness is observing that cat, assuming cat's own consciousness is off, if in the quantum limbo, then catness is not instantiated. This is admittedly tricky, but one could say the paradox only arises if we insist on an absolute state of the cat irrespective of observation. Buddhism denies absolute states. The cat's state is dependently real relative to an observer. For the cat itself, one could argue the cat is an observer of itself. So perhaps quantum weirdness at that scale would have collapsed because the cat's own consciousness serves as an observer. In fact, many argue Schrödinger's cat can't practically be in a coherent superposition because it will decohere due to interaction with environment, similar to saying the cat's own metabolism or consciousness measures the poison. So Buddhism would likely resolve it by saying it's not possible for a sentient being to be in an indefinite state of life-death to that being's own perspective. To an outside perspective, if we haven't looked, we simply don't know, and that's fine. There's no single reality of the cat we need to insist on. We accept our knowledge is limited until observed. This aligns with the Buddha's silence on certain questions. Sometimes it's just unanswered because it doesn't lead to enlightenment, or because it's not applicable. In the case of the cat, Buddhism would encourage focusing on what can be known and what matters. If the cat's alive, help it. If dead, accept it. The paradox as a logical puzzle doesn't torment the Buddhist mind because it already rejects inherent existence and absolute binaries. Quantum dilemma, for quantum entanglement and non-locality. Entanglement shows that particles can be connected in ways that defy classical separateness. Measuring one instantly influences the state of another far away in terms of correlations. This challenges the notion of independent existence of distant objects, Einstein's separability. It suggests a holistic reality where parts are not truly separate. Buddhist resolution. If any concept in science screams dependent co-arising, it's entanglement. Buddhism's worldview is profoundly holistic. Nothing exists independent of the whole. There's a famous analogy in Mahayana Buddhism, which, while a bit later development, stems from the same non-dual understanding called Indra's net, a vast net with a jewel at each node, each jewel reflecting all others infinitely. This is meant to illustrate the interconnectedness of all phenomena. Each phenomenon reflects or contains all others in some way. While Theravada texts don't use that image, they do say things like when this is that is, from the arising of this that arises, implying a network of interbeing. The Avatamsaka Sutra, a Mahayana text, explicitly describes a cosmos of radical interpenetration of phenomena. Quantum entanglement, where two particles anywhere in the universe can be linked as if they are one system, is a physical manifestation of the kind of connectivity Buddhism might poetically assert in the moral sphere. Karma connects distant events, or existential sphere. All beings have been each other's mother, etc., due to interconnected rebirths. From a more Theravada perspective, entanglement could be seen as a demonstration that the idea of discrete separate things is an abstraction. Ultimately, there are conditions and relations, but not standalone entities. When two particles are entangled, they are effectively one composite system with a single, non-factorable state. Buddhism has the concept of anattā not just individually, but also that nothing has self, which includes the idea that boundaries we draw are conventional. So two entangled particles are only two conventionally. Ultimately, there's a single phenomena spread over space. In dependent origination, we might say those two particles share a portion of a causal chain. Non-local correlations break the classical idea that to affect something it must be in contact or via a field at limited speed. Buddhism's viewpoint, not constrained by mechanistic localism, would say distance is somewhat illusory. After all, mind siddha is not in space in Buddhism. It's a phenomena that arises interdependently with matter but is not located in 3D coordinates. So a connection that is instantaneous is not troubling if one sees space and time themselves as part of the interdependent world, not as absolute. Indeed, advanced Buddhism and modern physics both see space and time as relative or as constructs. The Pali Canon has a teaching that nirvana is akata unmade asamkata unconditioned, and beyond time akalika, suggesting that the ultimate truth isn't bound by space-time. While entanglement isn't nirvana, it hints that the fabric of reality has non-local features, aligning with an intuition that the deepest level of reality might be a unified field rather than separate pieces. Physicist David Bohm proposed an implicate order where separation is an illusion and everything is enfolded in everything. He was influenced by conversations with Krishnamurti and was aware of Buddhism and Eastern thought. The Dalai Lama, one of Bohm's friends, often analogizes quantum interconnectedness to praticca samutpada, dependent arising. In one interview, the Dalai Lama said that in quantum physics, everything is interconnected and nothing exists independently, which is very much like the Buddhist understanding of reality. Another point, entanglement challenges classical causality, since you can't say one particle's measurement caused the other's state in time. They appear together. Buddhism's view of causality, idappaccayata, is more nuanced than linear cause-effect. It allows for simultaneous conditions and feedback loops like consciousness, name form. So two entangled particles could be seen as two outputs of one cause or as mutual conditions in a larger system. Buddhism has concept of sahajatapaccaya condition of arising together. Entangled particles arise together, and thus even when separated they remain in a kind of sahajata relation born of same source, maintaining a non-local link. Again, Buddhism finds this unsurprising under its worldview. Quantum dilemma. 5. Lack of objective reality. Is reality merely subjective or information-based? Quantum interpretations struggle with whether the wave function is real or just represents knowledge. If the latter, then reality might be fundamentally about information, what we know and can know, which brings a subjective element into the picture of the world's fabric. Some fear this edges into solipsism or anti-realism. Buddhist resolution Buddhism denies both pure realism and pure nihilism. It presents a middle way. Ontology phenomena are real. As phenomena, the Buddha did not say the world is a dream. He operated within cause and effect quite realistically, but they are empty of an inherent essence and exist only in dependence on conditions, including observation. This could be seen as a kind of contextual realism. The world is not unreal. When you stub your toe, the pain is real enough. But its mode of existence is not what we naively think independent things. It exists as a tapestry of interrelations that depend on perception, name, concept, and mind for their articulation. In modern terms, one might align this with the idea that information and experience are fundamental, and what we call objective reality is a consistent set of information that conscious agents experience. Not dissimilar to some interpretations like Cubism, which say quantum mechanics is about personal probabilities of an agent, but all agents in a shared world will update probabilities in harmonious ways. Buddhism can accommodate an information-centric view because one of the aggregate is sanya, perception, recognition, and another is vijnana, discernment. These are processes of knowing, categorizing, and they are part of what constitutes reality for us. Buddhism effectively says the world you know is shaped by the mind's perceptions and conceptions. For example, MN1 Mulapariyaya Sutta explains how different beings perceive the world through the filter of their tendencies, and an enlightened one perceives without distortion. So reality appears differently based on the mind, which is why we humans see a solid world a microphysicist with instruments sees wave-particle duality, a deity might see something else. None of those views is absolutely objective beyond perspective. However, Buddhism would not go so far as to say it's all in your head, rather mind and world co-arise. So it's neither the purely subjective idealism nor the naive realism. In quantum foundations, there's a notion now that reality might be participatory. John Wheeler's phrase, participatory anthropic principle, we participate in bringing about reality by the questions we ask. This fits nicely with Buddhism's participatory cosmos. Sentient beings' actions, karma, actually shape the world they experience literally through rebirth realms and such. So in Buddhism, mind participates in the creation of reality on an ongoing basis, not in the trivial sense of like, I think of a cake and it pops into existence, but in the profound sense that the entire cosmos is the playing out of karmic and natural laws that include the mind's role. For example, collective karma in Buddhism accounts for why we share a world with consistent laws. Beings with similar karma are born in similar realms. This is analogous to saying a set of observers share a reality because they have consistency in their information and interactions. Thus, Buddhism provides a framework in which the absence of a single objective reality is not a bug, but a feature of the universe. The ultimate reality, Paramatha, in Buddhism, is not a collection of external objects, but the suchness of phenomena when seen without delusion. And what is that suchness? It's emptiness contingency process, which is exactly what quantum physics finds when it drills down no little billiard balls, just energy fluctuations fields, probabilities entanglements, a world more akin to a thought than to a machine. As the quantum physicist Werner Heisenberg reflected after conversations with the Indian poet Tagore, some of the ideas that had seemed so crazy in quantum theory suddenly made much more sense. It was the recognition that relativity, interconnectedness, and impermanence as fundamental aspects of physical reality, which had been so difficult for us physicists, was the very basis of Indian spiritual traditions. He realized Eastern philosophy had long accepted things that physics was just discovering. Indeed, the Buddhist teaching from 500 BCE states that any worldview dividing things into strictly existence versus non-existence is inadequate. Instead, existence is a web of conditions, a both slash and slash, neither situation relative to those extremes. To put it succinctly, Buddhism resolves the quantum crises by offering a worldview where observer and observed are a single system. Thus, asking what a particle is doing alone is as meaningless as asking what dance a single hand clapping can do. It takes two subject-object to tango, so to speak. Once you have two, you have a relative reality. Uncertainty is natural because reality is not a set of fixed things but a fluid process. Knowledge is always of a momentary event, and you can't freeze a moment to capture all aspects. This aligns with why we can't simultaneously know complementary variables. The act of freezing one aspect sacrifices another, just as focusing on one aggregate distracts from the others. Non-locality and entanglement point to the underlying unity. Buddhism already treats the apparent multiplicity as conventional truth and unity, or non-separateness as closer to ultimate truth. Minds and matter are all parts of a grand net of causation. Action at a distance might be how karma works over lifetimes too. unseen connections spanning time and space. No intrinsic properties, anattā, exactly what quantum says about unmeasured observables. They're not just unknown. They might be undefinable, there's no hidden value. This echoes empty of own being. The electron has no fixed being. It only comes with properties when it interacts with something else, just as Buddhism says nothing has self-only qualities arising due to conditions. We should also highlight that Buddhism not only philosophizes, but offers a verification method, meditation, and insight practices. A scientist might ask, how can I be sure these Buddhist assertions are more than speculative philosophy? The Buddha would answer, come and see, ehipassiko. For instance, one can observe in meditation the momentary arising and passing of phenomena in one's body-mind, directly seeing impermanence and dependent arising at work. Advanced meditators sometimes report experiences of non-duality, where the usual boundary between observer and observed dissolves in experience is just one flow. This is essentially the subjective counterpart of what quantum physics hints objectively. The separation is an illusion of scale. In a deep state of insight, a person might feel the truth of interconnection and emptiness that physics can only infer by math. Thus, Buddhism doesn't just assert these principles. It provides a path to realize them. At this point, we have, in effect, built a bridge from the puzzling phenomena of quanta to the liberating insights of Dharma. But let's not simply keep it theoretical. In the next chapter, we will give some concrete examples and note where contemporary science and Buddhism have explicitly intersected. Many scientists themselves have been inspired by or noticed parallels with Buddhism and other Eastern philosophies when grappling with quantum mechanics and consciousness. We'll mention a few and also see how modern neuroscience on perception ties in nicely with Buddhist doctrines of mind. This will further reinforce how Buddhism provides not just a resolution to intellectual puzzles, but a potentially transformative understanding of reality. 4. Real-world examples and scientific correlations. The dialogue between Buddhism and science, especially physics and neuroscience, has been vibrant in recent decades. It's no longer unusual for a conference to have a Buddhist monk and a quantum physicist on the same panel discussing the nature of consciousness or reality. Let's look at some specific instances where Buddhist principles align with scientific findings and note cases of famous scientists engaging with Buddhism or related philosophies. Quantum entanglement and interdependence. In 2015, an experiment famously called the cosmic bell test used distant quasars' light to decide measurement settings and close the last major loopholes in confirming quantum entanglement's non-local correlations. The result, nature really is spooky in Einstein's terms. Entangled particle pairs showed coordinated behavior that could not be explained by any signals between them, at least none that respect the speed of light limit. This implies that, in some sense, once two particles interact and become entangled, they cease to be two independent objects. They become a single system no matter the distance. Buddhism's dependent origination prepares us for this by teaching that phenomena are not truly separate. They emerge from common causes and conditions and remain connected. In fact, Buddhist philosophy would predict that trying to analyze reality into isolated independent elements will always fail at some level because reality is a continuum of relationships. Modern physics has indeed found that at fundamental levels the idea of distinct particles breaks down. Quantum field theory suggests it's all one field with quanta excitations. Entanglement suggests a single state for multiple particles. The Dalai Lama, who has engaged in many dialogues with physicists, once remarked that the quantum concept of entanglement is very close to the Buddhist understanding of interdependence. The Dalai Lama even playfully said if science definitively proved something that contradicted core Buddhist scripture, Buddhism would adapt, for example, about cosmology. But so far, he noted, science is actually confirming Buddhist insights in many areas, especially concerning the mind and the interconnectedness of reality. The Mind and Life Institute has been holding dialogue since the 1980s between Buddhists and scientists, and quantum interconnectedness is a frequent topic. Modern neuroscience on perception and consciousness. Enter the brain science realm. Neuroscientists like Dr. Anil Seth have voiced ideas strikingly similar to Buddhist teachings. Seth famously said, "We're all hallucinating all the time. When we agree about our hallucinations, we call it reality." This encapsulates the notion that what we perceive isn't a direct readout of an objective world, but the brain's constructed best guess. Our sensory data is noisy and ambiguous. The mind uses prior knowledge predictions to generate a coherent world. This is essentially the concept of sankhara and sanya mental formations and perceptions actively shaping experience. Buddhism has long claimed that what we experience is in large part a projection of our mind's own tendencies, sankhara. For instance, when we see a snake instead of a rope due to fear, that's a gross example of the mind hallucinating reality. But on a subtler level, all perception is kind of like a controlled hallucination, as Anil Seth says. The brain doesn't present reality unfiltered. It presents a simulation based on sensory inputs. Buddhist meditation practices like mindfulness and vipassana involve closely observing how perceptions and thoughts arise and how we superimpose concepts on raw sense data. Advanced meditators sometimes report a breakdown of solid perception, seeing reality as flickering sensations rather than solid objects. This directly aligns with neuroscientific accounts that our sense of solidity and continuity is a constructed illusion. Giulio Tononi's integrated information theory. TT posits that consciousness corresponds to the capacity of a physical system to integrate information, and this theory boldly suggests consciousness is a fundamental property of certain systems, in a way introducing a bit of panpsychism that basic awareness might exist in simple forms, even in small systems. Tononi says a system's consciousness is an intrinsic fundamental property of any physical system given the right causal structure. This challenges the conventional materialist view that consciousness is an emergent fluke. It implies that the universe might be inherently imbued with proto-consciousness in its structure. Buddhism, without jumping to say particles are conscious, does assert that mind-nama is a fundamental aspect of reality and not an epiphenomenon. In Buddhist cosmology, mind and matter coexist at all levels. Even the tiniest life forms have some consciousness, however faint, and even realms considered primarily mental still have some form of matter, and vice versa in fine material realms. The information-centric worldview of IIT and quantum information theory, which says, maybe it from bit matter arises from information, resonates with the primacy of mind and knowledge in Buddhism. In particular, quantum cognition is a new field where cognitive scientists borrow the mathematics of quantum theory to model how humans think, because human decisions sometimes violate classical logic but can be explained by quantum-like superposition of thoughts, etc. This cross-pollination is a sign that the quantum and the mental might share deep structural similarities. Buddhism, which essentially applies a scientific approach to the mind, wouldn't be surprised, because both mind and matter are governed by universal principles, Dharma, niyama, in its view. Physicists drawn to Buddhism Eastern thought. Historically, several pioneers of quantum mechanics and modern physics explicitly drew parallels to Eastern philosophies. Erwin Schrödinger, who formulated the wave equation, was deeply influenced by the Upanishads' ancient Indian philosophical texts. He wrote about the idea that consciousness is a singular, the total number of minds in the universe is one. This idea is more aligned with Vedanta Hindu philosophy than Buddhism. Buddhism wouldn't state one eternal self, but it shows an Eastern influence. Schrödinger's idea that all apparently separate minds are manifestations of one mind resembles certain Mahayana Buddhist or Advaita Vedanta views. He found the Western materialistic conception of separate observers inadequate. In his essay, Mind and Matter, Schrödinger echoes the notion of Maya illusion in multiplicity. His openness to Eastern thought was arguably fertilized by the bizarre unity suggested by quantum theory. Niels Bohr famously took the yin-yang symbol as part of his coat of arms when knighted, symbolizing complementarity. The notion that opposite concepts, wave and particle, for example, are both necessary and only together give the full description, just like yin and yang. This was directly inspired by Eastern philosophy's comfort with paradox and dynamic balance. Bohr felt that Eastern thinkers had long accepted the need for multiple perspectives to capture reality. The quote we gave earlier, where Bohr says splitting reality into subjective and objective is not fruitful, also shows a holistic mindset akin to Buddhism's. Werner Heisenberg, as mentioned after talking with Rabindranath Tagore, who had dialogues with Einstein as well about reality, realized that what felt philosophically disturbing in quantum physics, the role of the observer, the lack of absoluteness, was already the very basis of Indian spiritual traditions which emphasize impermanence and interconnectedness. Heisenberg subsequently wrote more openly about philosophy, acknowledging Plato and Eastern thought in thinking about quantum reality. He once said modern physics might be closer to Plato's philosophy of forms than to Democritus's atoms. Interestingly, J. Robert Oppenheimer, the lead scientist of the Manhattan Project, studied Sanskrit and read the Bhagavad Gita. He famously quoted it upon the Trinity atomic test, "Now I am become death." Less known is that Oppenheimer also compared the quantum worldview to Buddhism, saying the general notions about human understanding, which are illustrated by discoveries in atomic physics, are not in the nature of things wholly unfamiliar, wholly unheard of, or new. In Buddhist and Hindu thought we find the most sustained and continuous exploration of these problems. Notice he included Buddhist thought there. David Bohm, a later quantum theorist who proposed a holistic interpretation, the implicate order, had substantial dialogue with the Dalai Lama and was greatly interested in consciousness. While Bohm wasn't explicitly a Buddhist, his notions of an undivided wholeness and the idea that separate objects are like eddies in a stream, localized but not fundamentally independent, strongly evoke Buddhist-like metaphors. Bohm once said, "Deep down the consciousness of the world is one." This is a basic truth of all great religious traditions. Again, that statement could align with a Mahayana Buddhist idea of Buddha nature, or simply the interconnected consciousness in dependent arising. Henry Stapp, a contemporary quantum physicist, has written about quantum mechanics and mind, even referencing Buddhist philosophy as potentially relevant in understanding consciousness's role in quantum processes. He suggested that quantum theory might allow for mental intention to affect physical outcomes, a controversial idea, and he cited Buddhist mental discipline as evidence that trained minds can have profound effects, implying an interplay of mind and matter. The Dalai Lama has engaged with scientists extensively. In 2005, at the Mind and Life conference, he was asked about quantum physics and said with a smile that if he were not a monk, he would have been an engineer or scientist because these parallels fascinate him. He noted how Buddhism for centuries has classified matter in terms of perceptible qualities, earth, water, fire, air elements, and how modern physics breaks matter into energy, and how both recognize that solid matter is mostly empty space. A fact the Buddha illustrated by asking what is the self in this body if it's just elements that break down. Such dialogues have led to neuroscientific studies on Buddhist meditators' brains, and conversely Buddhists adopting scientific findings into their philosophical schema, like using the Big Bang model in updated cosmological explanations rather than clinging to ancient cosmology. Neuroscience of selflessness. Modern neuroscience also increasingly indicates that the self is a constructed narrative of the brain. There's no single point where a soul or self sits. Different brain networks handle different aspects, memory, decision, sensation, and the unity is illusory. This beautifully corroborates anattā, the Buddhist doctrine of no self. Neuroscientist Thomas Metzinger wrote The Ego Tunnel, describing how the sense of self is like a tunnel illusion the brain creates. Meanwhile, Buddhist texts like SN 22.59 Anattā Sutta argued logically and experientially that no aspect of body or mind can be taken as self. Now, fMRI scans and experiments like the rubber hand illusion, where you can feel ownership of a fake hand, show how fluid and delusional our self-model is. In clinical psychology, practices derived from Buddhism like mindfulness help people see thoughts as just events, not me or mine. The reduction in identification with self has therapeutic benefits, reducing depression relapse, etc. This is practical evidence for Buddhism's claim that clinging to a self is the root of suffering. Letting go of that identification yields relief. In sum, we find a convergence quantum physics is revealing a world that is relational, indeterminate, and holistic. Neuroscience and psychology are revealing a mind that is constructed, not fixed, and a self that is illusory. These are the very themes Buddhism has expounded. Neither the Buddha nor modern scientists claim these insights are immediately obvious. They often go against our instincts. Quantum mechanics is famously non-intuitive. Anattā is also hard to accept emotionally. But through inquiry and evidence, both have arrived at these counterintuitive truths. It's important to acknowledge that science and Buddhism use different methodologies and have different aims. Science wants to describe and control phenomena. Buddhism aims to liberate one from suffering by transforming one's understanding and consciousness. Yet when it comes to describing what reality is like, especially at extremes, very small scale or deep introspective insight, they come remarkably close. This suggests that truth is truth. If one sincerely investigates, the findings will eventually line up whether one uses a particle collider or a meditation cushion. The famous physicist and mathematician Henri Poincaré once said something akin to the most important facts are those which show the connection between things. Buddhism and physics both are uncovering those connections. Let's recall a particularly illustrative anecdote. Heisenberg, visiting India, met Tagore, a leading Indian philosopher-poet. Tagore's line of thought, influenced by Vedanta, not exactly Buddhism, but sharing the Eastern emphasis on consciousness, was that the reality of the universe is a unity which is experienced through our consciousness. At first, Einstein, in a discussion with Tagore, balked at that, insisting the moon is there, even if no one looks. Tagore, like a Buddhist, might responded that the tree falls in the forest still produces vibrations, but they become a sound only when a consciousness is there to perceive it, a proto-formulation of the Copenhagen view. In the end, Einstein could not convince Tagore of an observer-independent reality. Tagore asserted that this world is a human world. The scientific view as well is also that of the human mind. Einstein left unconvinced at the time, But ironically, quantum physics ended up siding somewhat with Tagore's viewpoint. This conversation is documented and has become a classic East-West discourse on reality. Now, Einstein wasn't wrong to seek an objective reality. Indeed, many later interpretations, like many worlds, try to preserve realism by saying the wave function never collapses, so reality is objective, but we just see one branch. Buddhism, however, would be more at home with something like the many-minds interpretation, a variant where each observation branch corresponds to a mind's experience or an information-based interpretation. Buddhism might say all possible outcomes exist as potentials. This is somewhat like the concept of bija or karmic seeds in Yogacara Buddhism, seeds that can germinate given conditions. When conditions meet observer with object, a particular seed outcome manifests. Others remain unmanifested until perhaps other conditions, maybe other worlds, etc. It's speculative, but the parallel is their karmic seeds equal sign quantum superpositions, observing equal sign conditions, ripening a particular karma outcome. We should be cautious not to claim Buddhism had quantum physics in ancient times. It did not have the technological or mathematical specifics. What it had were deep philosophical and experiential truths about reality that happen to align with what we find when we push science to its limits. This suggests complementarity science provides precise quantitative models and technology. Buddhism provides qualitative insight and existential significance. Together, they give a fuller picture. To ground this with one more real-world example, mindfulness-based stress reduction, MBSR, is a therapeutic program derived from Buddhist meditation, stripped of religious language. It has been shown to help with chronic pain stress anxiety by teaching people to observe sensations and thoughts non-judgmentally. Essentially, it trains people in a bit of Buddhist perspective that sensations are transient, that pain is not a solid monolith, but a series of moments that can be observed, that the self-experiencing pain is also a construct. Patients often report after training that the pain is still there, but it bothers them less because their relationship to it changed. They see it as phenomena, not as my unbearable pain. This is a practical resolution of suffering through understanding impermanence and not self. In parallel, one could say, if we as a civilization truly internalize the quantum Buddhist view of reality, our relationship to the world might change, perhaps with less greed and exploitation, because those are based on seeing the world as a collection of separate things to grab or fear. If we see unity and interconnection, compassion naturally arises. Buddhism heavily emphasizes that understanding emptiness interdependence must be accompanied by compassion, since all beings are part of one web. Thus, not only does Buddhism resolve quantum puzzles intellectually, it also guides us in how to live with these truths. Instead of existential dread that nothing is real, everything is uncertain, Buddhism transforms that into a liberating insight because nothing has fixed essence, everything can change. Suffering can end because we are all interconnected, every action matters, and compassion is rational. The crisis in physics is an opportunity in philosophy and spirituality. It's pushing humanity to move beyond a mechanistic, fragmented view into a holistic, mind-inclusive worldview. As we approach the conclusion, recall how we started with a provocative question: could the Buddha have solved the quantum riddles? By now, it should be clear that while the Buddha didn't talk about electrons or Schrödinger's cat, the principles he taught address the essence of these riddles, the interplay of observer, and observe the non-duality of subject and object, the emptiness of inherent characteristics, the continuous change of phenomena, and the profound interconnection underlying apparent separateness. In the final section, we will summarize how Buddhism offers not just a patch for quantum mechanics, but a profound unification of the scientific and spiritual quest for truth. We will consider what it means for our understanding of reality that two such different approaches converge, and how embracing this convergence can benefit both our scientific progress and our personal wisdom. Conclusion. We began with a crisis. Quantum physics shook the very notion of an objective reality out there independent of observers. It forced upon science the uneasy truth that the role of the observer, the act of measurement, and the consciousness of the scientist cannot be cleanly separated from the phenomena being observed. Reality at the quantum level turned out to be startlingly interactive, impermanent, and relational. This left many physicists philosophically unsettled, searching for interpretations that could restore some sense of an objective world, or at least make peace with the lack of one. In our journey, we found that the teachings of Buddhism, in particular Theravada Buddhism's original doctrines, anticipated a framework in which such quantum strangeness is not strange at all, but expected. Buddhism's dependent origination tells us nothing exists on its own. Everything exists due to something else. Thus, an electron has no standalone existence with intrinsic properties. It exists in a web of conditions, the experimental context, the observer, etc. The observer effect, then, is no paradox. The observer was always in the equation, so to speak. Buddhism's teaching of impermanence tells us reality is in constant flux and fundamentally uncertain. So Heisenberg's uncertainty principle and the probabilistic nature of quantum outcomes simply reflect the way nature is, not deterministic clockwork, but a spontaneous, ever-changing flow. The doctrine of not-self removes the idea of fixed essence. Particles don't have an essence, nor do people. So, superpositions, multiple potential states, and collapses, choosing one, do not violate an essence. There was none to begin with. And the interconnection of all things, which Buddhism emphasizes through teachings like when this exists, that exists, and compassion for all sentient beings, finds a physical echo in quantum entanglement, distant particles acting as one. What does this mean for our understanding of reality? It means that the universe is not a collection of separate objects, but an organic whole of interdependent events. The role of mind and consciousness is central, not incidental, in this whole. Reality is participatory. Our observation is woven into the fabric of what unfolds. As John Wheeler said, we are not mere spectators, we are participants in the great play of the cosmos. The Buddha long ago taught that each of us constructs our world through our perceptions, intentions, and actions. And thus, we bear responsibility for the world we experience. One might ask, is this just a poetic coincidence, or does it point to something deeper? It suggests that rational inquiry science and contemplative inquiry Buddhism, when pushed far enough, converge on a similar truth. In Buddhism, this truth is sometimes called Dharma dhatu, or the lawfulness of reality. Everything is empty shunya, yet interarising, and the only ultimate thing that can be said to exist is nirvana, which is outside conditional phenomena. In physics, we haven't found nirvana, but we have found that classical things dissolve into quantum fields and perhaps deeper into just information or mathematics. There's even a movement in physics toward quantum monism, the idea that the universe is fundamentally a single quantum state, and what we see as particles are like ripples on that one ocean. That is strikingly resonant with Buddhist holistic monism, not monotheism, but the idea of one underlying reality beyond multiplicity. For the audience watching this documentary, likely well-versed in physics or philosophy, the takeaway should be both intellectual and personal. Intellectually, we've seen that Buddhism provides a coherent philosophical foundation that can accommodate and even predict the features of quantum physics. Instead of needing to invent 10 new physical interpretations, one can reflect on the Buddha's insights for a conceptual clarity. The world is a grand interconnected system where mind and matter co-evolve. This doesn't solve technical questions like how to unify quantum mechanics with general relativity. The Buddha didn't teach about gravity explicitly, but it might guide our intuition. For instance, some physicists suspect that consciousness could be a fundamental aspect of the universe, as in some interpretations of quantum mechanics or the views of Penrose Hameroff, etc. Buddhism would agree that without acknowledging consciousness, any theory of everything is incomplete, because any theory itself arises in consciousness. Personally and practically understanding reality in this Buddhist way can be transformative. The quantum crisis troubled many because it undercuts the notion of a solid, reliable world that can be unsettling. But Buddhism reframes that not as a loss, but as a liberation. If nothing has inherent existence, then everything is free in a sense, free to change, free of fixed constraints. This means we too are free to change. Our identities, our perceptions, even what we think of as impossible can shift. The uncertainty that quantum physics forces upon us can actually be embraced as the same uncertainty that gives room for free will and creativity. If the universe were strictly deterministic, novelty and genuine choice would be illusions. In a dependently originated universe, intentional action, karma matters. It can literally shape outcomes. Indeed, some interpretations of quantum mechanics, like the von Neumann-Wigner hypothesis, even entertain that mind influences collapse. Whether or not that is physically true, Buddhism squarely says your mind influences your reality by shaping your perceptions and through karma, even influencing what you encounter. Moreover, seeing the world as deeply interconnected fosters compassion and ethical responsibility. In classical physics, one might view the world as a bunch of separate billiard balls. One could feel isolated and insignificant, or conversely feel one can exploit others with no consequence. In the Buddhist quantum worldview, nothing exists in isolation, and every action reverberates. It becomes clear that harming others is harming oneself in the web of dependent origination. Suffering caused will come back to the causer. Many Buddhist masters have used this logic to encourage compassion, since we are all part of one interdependent whole. Love and altruism are the only attitudes that make sense. Interestingly, some scientists like Erwin Schrödinger also arrived at an ethical conclusion from unity. He wrote to regard the experiencing self as identical with what lies outside seems the only possible expedient. In mystic language, this is called the path of compassion. His one-mind idea led him to compassion as the logical ethics. In closing, we can affirm that Buddhism's stance is neither a physics theory nor a vague mysticism, but a middle way that can absorb the findings of science while providing an orienting vision of reality that is both rational and profoundly meaningful. It asserts that reality is neither purely material nor purely mental. Those are two sides of the same coin. Reality is interaction process dependence, and ultimately, in Buddhism, reality has the facet of nirvana, the unconditioned element which might be analogized very loosely to the ground state of the cosmos beyond quantum fluctuations, a peaceful emptiness that is full. When one truly understands dependent origination, the Buddha said it's equivalent to understanding the Dharma entirely. Perhaps understanding quantum reality in this new light is a step for modern people towards a similar wisdom. The crisis in quantum physics, therefore, could be seen as a catalyst pushing us to broaden our framework. By integrating Buddhist insights, we get a larger paradigm in which mind is not a latecomer, but a fundamental player, and in which reality's mystery is not a problem to solve away, but a truth to awaken to. The Buddha's teachings ultimately invite one to experience this truth, not just think about it, through meditation and ethical living. For a physicist, that may sound like a different endeavor, but many have found that meditative practice actually complements scientific creativity as it calms the conceptual mind and can lead to deeper intuitive leaps. As we end this journey, consider this beautiful synergy. Quantum physics revealed a cosmos more interlinked and subtle than we ever imagined. Buddhism had long pointed to such a cosmos, and furthermore provided a path to inner freedom within it. Science gave us equations. Buddhism gives us equanimity. Both together give us a fuller understanding of the ultimate truth about reality, a reality that is not cold and alien, but one where when we deeply see its nature, we also see our own nature. The knower and the known become one. In that unity, the quantum enigma and the self are both dissolved into a clear light of understanding. The Buddha's last words were, "Be a light unto yourselves." In the context of our discussion, one might interpret, don't rely solely on external apparatus, be it scientific or dogmatic, to illuminate truth. Use your own mind's light of awareness. Now armed with both cutting-edge science and ageless wisdom, we are perhaps better equipped than ever to shine that light. The crisis in physics might well be resolved not just in laboratories or equations, but in the enlightened mind that directly perceives the way things are impermanent, interdependent, and empty, yet marvelous, luminous, and infinitely meaningful. In summary, Buddhism provides the conceptual and experiential key to unlock the quantum riddles by understanding that reality is a dependent co-arising of observer, and observed with no fixed essence underneath, we find a satisfying resolution to the puzzles that have haunted physics. Rather than despair that reality isn't real, we rejoice that reality is a grand interplay where consciousness and cosmos dance. The Buddha discovered this dance within his own mind. Today's physicists discover it in subatomic experiments. How wonderful and mysterious that these two roots converge. It suggests that truly truth is one, paths are many. And when science and spirituality meet, human understanding takes a leap, potentially as revolutionary as the quantum leap itself. As you reflect on this, consider taking this knowledge not only into intellectual debates, but into your own direct experience. Challenge your preconceived notions. Are you the observer truly separate from the world you observe? Or are you part of an indivisible process? Explore this question in your life. When you change your perspective, does your world change? Buddhism would say yes. So, armed with quantum evidence and Buddhist wisdom, experiment in the laboratory of your immediate experience. In doing so, you might find not only the resolution of physics' conceptual crisis, but also a resolution of the human existential crisis, the search for meaning and connection in a seemingly fragmented world. The ultimate truth hinted by both is that the fragmentation is an illusion, wholeness is the reality. Thus, the quantum physics crisis is resolved by realizing it was a crisis of perspective. The Buddha's teachings provide that new perspective where mind and matter unite in a single reality described by dependent origination. With this understanding, we step into a new paradigm where science and spirituality not only coexist, but enhance each other, shining light on reality's deepest secrets and illuminating the path to wisdom. Thank you for accompanying us on this deep exploration. May it inspire further curiosity, contemplation, and perhaps even a bit of personal insight. In the end, as the Buddha would emphasize, don't take anything on faith. Investigate for yourself both through scientific rigor and introspective clarity. The truth will stand up to scrutiny, and it is liberating.